Hi everyone, welcome to our presentations on asking crowdworkers to write entailment examples, the best of bad options. My name is Clara, I'm a postdoc at the New York University. This work is a collaboration with Luigi Chen and Sam Bowman. Natural language inference is the task of determining whether a premise entails a hypothesis. For example, given the following premise, the dogs are playing in a nearby park, and a hypothesis, the lady took the dogs to the park. This hypothesis can be true or can also not be true given the premise. So if we have three class entailment labels, entailment, neutral, or contradiction, most people will likely label this pair as neutral. Here, we follow format from SNLI, MNLI, the two largest NLI data, and the most recent adversarial NLI using three entailment classes. In recent years, NLI data have been useful for NLU benchmarking and as a pre-training task for transfer learning. So let's now look at how these datasets are usually created. First, we sample premise sentences from a large unannotated corpus. We then give them to crowdworkers, which then ask to write three labeled hypothesis sentences, one for each entailment class. Usually for evaluation set, there will be an additional validation process where different crowdworkers will validate if the label is correct. And the good thing about this protocol is that it will naturally collect datasets with balanced label distribution. So this is a good protocol, but there has been no study that directly evaluate whether this protocol is optimal to collect entailment data. And human writing hypotheses also have non-artifact issues, which is patterns in the data that can reveal the true labels. For example, it has been shown that the negation is highly correlated with contradiction. So in this paper, we asked, can we do better by pairing up sentences automatically and just collecting labels? We proposed two new protocols, which are shown on the middle and on the right side. Our first protocol uses a sentence similarity-based method to pair similar sentences from large unannotated corpora and then give them to the crowdworkers to label. Our second protocol takes multilingual comparable sentences and uses machine translation systems to generate sentence pairs. The same as the similarity retrieval-based protocol, after this, we also need to give the premise hypothesis pairs to crowdworker for label. So why do we choose to do this? First, labeling takes less time and effort, which means we can possibly collect more data if we have a fixed annotation budget. It will also potentially remove primary source of annotation artifacts, which is human elicited hypothesis. However, there are also some drawbacks. First, it is not guaranteed anymore that we will have datasets with balanced distribution. The similarity and translation approach can be noisy, and finally, they could introduce new kind of artifacts. I will briefly discuss these protocols in details in the next few slides. So for our similarity retrieval or SIM protocol, first we take a big corpus, such as Gigaword or Wikipedia. We index them using FAISS, a fast library for indexing and retrieval. We then randomly sample premise sentences from the same corpus and then use them as queries to collect candidate hypotheses. Since similarity retrieval can be noisy, we then perform re-ranking using a set of handcrafted features such as similarity score from FAISS, name entity overlap, word overlap, etc. We also use a trained NLI model trained using a combination of SNLI, MNLI, and adversarial NLI data, and a Bayesian optimizer. This re-ranker is optimized so that we will have a set of sentence pairs with balanced label distribution. After that, given our premise hypothesis pairs, we provide this set to Crowdworkers to label. Our next protocol, which is translation-based approach or translate, takes a multilingual comparable sentence align corpus. For example, here, if we have a parallel corpus of English and Indonesian, we first machine translate the Indonesian sentences into English and then pair the translated English sentences and the original sentences as premise hypothesis pairs. Similar as our SIM protocol, we also provide these final premise hypothesis pairs to Crowdworkers to label. For our experiments, we collect in total 5 new datasets using premises from GigaWord and Wikipedia. The first two, base news and base wiki, are collected using the MNLI style protocol, which we treat as baselines. For our new protocols, we collect SimNews, SimWiki, and TranslateWiki. Here, news refers to datasets collected using premises from GigaWord, while wiki refers to datasets collected using premises from Wikipedia. To evaluate the usefulness of our protocols, we test them for generalization within NNI and also transfer learning, where we use them as intermediate test data. So here, for example, if we use Roberta pre-trained model, we first fine-tune them on our collected data, and then we fine-tune the model again on the target task. So let us now look into some statistics of our collected data. We first collect around 3,000 training examples for base news and base wiki. And then using the same budget, we find that our new protocols yield around 6,000 training examples each, which is twice more data than MNLI style baseline. Regarding the label distribution, we observe that SIM has slightly unbalanced distribution compared to the other protocols. We also analyze the word type overlap statistics, which is another known artifact for NLI. We find that our new protocols show higher overlap on entailment class compared to MNLI style baseline, which is probably undesirable for entailment data. We then check also the annotator agreement by measuring how many times individual labels agree with gold labels and the percentage of examples where there is no agreement, or in other words, no gold label. Here we observe that base protocol shows higher agreement than our new protocols, which suggests that maybe our new protocols yield noisier data than the baseline. So now let's see our results. How useful our new datasets for NLI generalization? We compare two variants of model based on Backoffers and Roberta fine-tuned with each of these datasets. And we test each model on various NLI data using the test data that we collect plus test data from MNLI and adversarial NLI. On average, we find that MNLI style baseline generalized better than our new protocols and perform on par with a model that is trained on a subset of 3,000 examples of MNLI data. Next, we also evaluate for transfer learning how useful our new datasets for transfer learning. Here we compare models using BERT and Roberta sentence encoders. For our tasks, we select 5 small to medium-sized tasks in the SuperGLUE benchmark, COPA, multi-RC, RTE, WIC, and WSC. We see here that our new protocols do not yield models that transfer better. Though there are some improvements, for example, for COPA and RTE, we don't see any clear patterns that our new protocols are more useful than MNLI style protocol. Finally, here are some examples of our collected data. We find that they are pretty reasonable as entailment data. However, they might not be as creative as human elicited hypotheses. For example, here both SimWiki and TranslateWiki have pretty similar premise and hypothesis, which probably not really useful for entailment data. More qualitative analysis can be found in the paper. So to conclude, in this paper, we propose two new protocols to collect entailment data that substitute human elicited hypothesis with automatically paired sentence pairs. Under fixed annotation budget, our new protocols yield twice as many examples as MNLI style baseline. However, we find that the collected data are noisier and yield to poor model performance both in NLI and transfer learning. Here we find that crowdworker writing is still the best known option for NLI. And our results are negative, but we hope this work will be useful for other researchers working in crowdsourcing in NLP, especially for natural language inference. Thanks, and I'm looking forward to the discussions.